This first section that we're going to be talking about is lesson 4.1, and it is on similar shapes and proportions. Similar shapes are shapes that have the same shape, but they do not have the same size. So they look exactly the same except one is bigger than the other. On similar figures, corresponding angles and sides are in the same position. So if you have two right triangles, if they are similar, they're going to look just the same, except one is going to be bigger than the other one. So corresponding sides would be the sides that if they were facing the same way, the ones that are on the same in the same position. So since these are facing the same way, this left side would correspond to the left side, the bottom would correspond to the bottom, and then this slanted side, the hypotenuse, would correspond to this slanted side, the hypotenuse. So this right angle would correspond to this right angle, and then the top angle would correspond to the top one, and the bottom right to the bottom right. So in similar figures, they have to meet these two criteria. The first one is that corresponding angles are going to be congruent or equal, and corresponding sides are proportional. And this symbol right here means similar. So we could say triangle ABC is similar to triangle DEF. And now if we wanted to label these triangles, if this one was ABC, since triangle A corresponds to D, so this would be a D, angle B corresponds to E, so this angle would be E, and C corresponds to F, so this one would be the F. So looking at these angles, this angle and this angle would be equal. So if we said this one was 40 degrees, then this one right here would also have to be 40 degrees. These two are both 90 degrees, so that would make this one 50 degrees, so this one would also have to be 50 degrees. Now looking at the sides, if the sides are proportional, that means that if we set them up as ratios, they would all simplify to the same thing. So if this side was 2 and this side was 6, that means that this side is 3 times as much as this one. So if this side was 3, then to figure out this side right here, the bottom, we would have to, since this is times 3, then we would have to multiply this side times 3. So if you multiply this side by 3 to get the 6, then we would have to also multiply this side by 3, so it would be 9. And let's say this side was 4, so we would also multiply it by 3 to get 12. So if we set these up as ratios, so we have a small triangle and we have a large triangle. So this side corresponds to here, so that would be 2 to 6. This bottom side would correspond to the bottom here, which is 3 and 9. This side corresponds to here, which is your 4 and 12. So all 3 of those ratios, if I simplified them, would give me 1 to 3, 1 to 3, and 1 to 3. So they are all proportional because they all simplify to the same thing. So on these two triangles right here, the sides, the angles are equal on all of them, and the sides are proportional. So that makes it similar because it fits both of those two criteria. So on this one, I'm wanting to know if these two triangles are similar. So it gives me all of the angles and it gives me all of the sides, and it's just wanting to know if they are similar or not. So they are turned the same way. So they are in the same position. So the bottom corresponds to the bottom, which is the 21 and the 7. This left side corresponds to the left side, which is your 8 and 24. And the 12 and the 36 correspond to each other. So if I'm looking at my sides, I'm going to compare the ones that I've colored the same. So this is my small triangle, and this would be my large. So looking at the blue first, that would be 8 to 24. Looking at the yellow, that would be 7 to 21. And the purple would be 12 to 36. Now if I simplified this, I would divide by 8 and get 1/3. Divide this by 7 and get 1/3. Divide this by 12 and get 1/3. So the sides are proportional. And then I need to look at the corresponding angles. So this angle, the top one is 34, this top one is 34. The bottom left is 106, this bottom left is 106. Bottom right is 40, bottom right is 40. So the angles are congruent. So since it fits both of these two criteria, then it is they are similar figures. Now on this one it says a rectangle made of square tiles measures 7 tiles long and 3 tiles wide. What is the length of a similar rectangle whose width is 9 tiles? So they already tell me these two rectangles are similar, but I'm trying to find one of the missing sides. So on the first one it says that it is 7 tiles long and 3 tiles wide. The other rectangle it says has 9 tiles as its width. So since it said 3 tiles wide and 9 tiles is the width, then I know that the 3 and the 9 correspond to each other. And I'm looking for the length, so I want to know how long this rectangle is. So just by looking at it, I know that, like we said, the 3 and the 9 correspond to each other. So to get from 3 to 9, I would multiply by 3. That would be times 3, so I have to do the same thing on the length. So times 3. So 7 times 3 would be 21 tiles long.